Imagine a world where the most advanced technologies of the 20th century were born not from peaceful innovation, but from the desperation and ideology of a tyrannical regime. This is the story of Nazi Germany's secret projects and how their echoes still shape our lives today. From the V-2 rocket that paved the way to space travel to the first jet fighters and stealth bombers, the Third Reich's engineers pushed the boundaries of science and industry at a terrifying pace. But what happened to these projects after the war? And how did German industrial know-how transform the global economy? In this video, we will explore the hidden infrastructure of the Nazi war machine, its post-war rebirth through Operation Paperclip, and the lasting legacy of German engineering in modern automobiles, aerospace, and even pharmaceuticals. This is not just history, it is the untold story of the technology you use every day. By 1943, Hitler's Germany was losing the war, but its scientists were working feverishly on a new generation of wonder weapons designed to turn the tide. Projects like the Messerschmitt Me 262, the world's first operational jet fighter, offered a glimpse of the future of aviation. Even more astonishing was the Horten Ho 229, a jet-powered flying wing with radar-absorbent materials that made it the world's first stealth aircraft. Meanwhile, at Peenemünde, Wernher von Braun and his team perfected the V-2 rocket, a ballistic missile that could strike targets hundreds of kilometers away in minutes. These projects required immense industrial coordination. Companies like BMW, Daimler-Benz, and Krupp retooled their factories to produce advanced engines, turbines, and synthetic fuels. But perhaps the most ambitious projects were the orbital mirrors, giant space-based reflectors designed to focus sunlight onto enemy cities, and the America bomber program intended to strike New York City. These were not just fantasies, they were funded and researched with the full might of the German industrial complex. By understanding these projects, we see the birth of modern rocketry, jet propulsion, and stealth technology under the darkest circumstances. As World War II ended, the Allies raced to capture German scientific expertise. The United States launched Operation Paperclip, a secret program that brought over 1,600 German scientists, engineers, and technicians to America. Wernher von Braun and his team were among the most prized. They were given new identities, homes, and jobs at U.S. military installations. Their V-2 rocket technology became the foundation of the American space program, from the Redstone and Jupiter missiles to the Saturn V that took humans to the moon. Similarly, jet engine pioneers like Hans von Ohain and Anselm Franz helped develop the first generation of American military jets. The Soviets conducted their own version of the program, Operation Osoaviakim, which forcibly transferred thousands of scientists to the USSR. This brain drain reshaped the global aerospace industry. In just a few years, German technology was flying in American and Soviet cockpits, and the industrial processes behind it were adopted by corporations like General Electric and Pratt & Whitney. The ethical cost was immense. Many of these scientists had used slave labor from concentration camps. Yet their knowledge was deemed so valuable that their pasts were whitewashed. The legacy of Operation Paperclip is a double-edged sword. It gave us modern spaceflight and jet travel, but it also normalized the integration of war criminals into peacetime research. Nazi Germany's industrial ambitions extended far beyond weapons. The Volkswagen Beetle, conceived as the people's car, was designed by Ferdinand Porsche under Hitler's orders. The original factory was built with forced labor, but after the war, it became the heart of Volkswagen, one of the world's largest automakers. The Beetle became a symbol of post-war prosperity, selling over 21 million units. The Autobahn, Germany's highway system, was initially a military project to move troops quickly, but it later inspired the construction of interstate highways globally. German innovations in engine design like fuel injection, turbochargers, and high-compression engines were developed for military vehicles and later refined for consumer cars. Companies like Bosch and Siemens, which provided electronic components for military projects, became leaders in automotive electronics. Even today, the German automotive industry's reputation for quality and performance is rooted in wartime engineering disciplines. The precision manufacturing methods, such as computer numerical control machining and automated assembly lines, were perfected for military production and then transferred to civilian use. When you drive a luxury car with superb engineering, you are experiencing a direct lineage from the factories that once produced panzer tanks and fighter planes. The German chemical and pharmaceutical industries were central to the Nazi war effort. IG Farben, a conglomerate of companies like BASF, Bayer, and Hoechst, produced synthetic rubber, fuel, and the deadly Zyklon B used in concentration camps. After the war, IG Farben was broken up, but its constituent companies became global pharmaceutical and chemical giants. Bayer, for example, developed aspirin and later produced antibiotics and medical supplies that saved millions of lives. The research methods and industrial processes refined under Nazi rule, such as large-scale chemical synthesis and high-pressure catalysis, were applied to peacetime products. The Haber-Bosch process, which fixes nitrogen from the air to make fertilizers, was perfected with slave labor but now feeds billions. Similarly, the development of synthetic fuels during the war laid the groundwork for modern petrochemical refining. Today, German companies like BASF and Bayer are among the most innovative in the world, but their roots are in the darkest period of modern history. The link between war and medicine is stark. The Nazis conducted horrific experiments on humans, but some of the data, such as on hypothermia and altitude sickness, were later used by Allied researchers. This ethical minefield continues to haunt the medical community, as the balance between scientific progress and human dignity remains unresolved. No technology better illustrates the dual-use nature of Nazi research than rocketry. Wernher von Braun's team designed the V-2 to terrorize London, but after the war, they turned their attention to space. Under the U.S. Army, von Braun's team developed the Redstone rocket, which launched America's first satellite, Explorer 1, in 1958. They then moved to NASA, where the Saturn V rocket, still the most powerful ever built, propelled Apollo astronauts to the moon. The technical challenges of guidance, propulsion, and materials were solved by engineers who had once worked for the Nazi regime. Their contributions are undeniable, but they also raised profound moral questions. Should we honor the engineering achievements while condemning the system that produced them? The space industry today, from SpaceX to Blue Origin, employs many of the same principles developed by von Braun's team. The computer algorithms for orbital mechanics, the manufacturing techniques for lightweight structures, and the telemetry systems all trace back to German secret projects. As we dream of colonizing Mars, we must remember that the foundations of that future were laid in the ashes of war. After the devastation of World War II, the German economy lay in ruins, but its industrial potential was quickly revived. The Marshall Plan provided funds, but the real engine of recovery was the Wirtschaftswunder or economic miracle. German companies leveraged their wartime technological advances to become global leaders. Siemens, which had produced communication and radar equipment, became a giant in automation and medical technology. BMW, an aero engine manufacturer during the war, reinvented itself as a luxury car maker. The German engineering brand became synonymous with precision, reliability, and innovation. This transformation was not accidental, it was a deliberate strategy to convert military technology to civilian use. The same factories that produced Messerschmitt fighters now built ventilation systems in trains. The blueprints for jet engines were modified for high-efficiency gas turbines used in power plants. Today, Germany is the world's fourth-largest economy, and its industrial output is deeply connected to its Nazi-era foundations. The ethical reconciliation with this past is ongoing, but the technological and economic impact is undeniable. When you use a Bosch dishwasher, ride a Siemens train, or drive a Mercedes-Benz, you are using products shaped by the secret projects of the Third Reich. Less known is the Nazi involvement in early computing and cybernetics. Konrad Zuse, a German civil engineer, built the Z3, the world's first functional programmable computer, in 1941. The Z3 was used for aerodynamic calculations for aircraft wings and guided missile fins. After the war, Zuse's patents were largely ignored by the Allies, but his work influenced early computer science in Europe. Meanwhile, the concept of cybernetics, the study of control and communication in machines and living beings, was partly developed by German researchers like Winfried Oppelt, who worked on analog computer algorithms for aircraft fire control. The V-2 rocket's guidance system also pioneered principles of feedback control that later became standard in industrial automation. These ideas were absorbed by American and British researchers after the war, leading to the development of modern digital computers and artificial intelligence. The German obsession with precision and systematic thinking gave rise to entire fields of engineering that now underpin the internet, robotics, and autocorrect algorithms. As we navigate the digital age, we are guided by the ghost of Nazi-era research, a fact that challenges our view of technological progress as always benevolent. The legacy of Nazi secret projects is a tapestry of brilliance and horror, of progress that came at an unimaginable human cost. From the rockets that took us to the moon to the luxury cars we drive, from the fertilizers that feed the world to the computers we use daily, the fingerprints of the Third Reich are everywhere. The engineers and industrialists who built this technology often escaped justice, and their inventions transformed the world for better and for worse. Understanding this history is not about justifying evil, but about recognizing the complex interplay between politics, ethics, and innovation. Today, as we push the boundaries of AI, space travel, and biotechnology, we must remember that technology is never neutral. It carries the weight of its origins. The story of German industry is a cautionary tale that great science can serve monstrous ends, and that our future depends on the choices we make about how we use knowledge. If you found this exploration illuminating, please like, share, and subscribe. There are many more hidden histories waiting to be uncovered. Thanks for watching, and see you next time.